Okay, this is the second part of this cubic question here, and it says, determine x, the coordinate of r of this cubic equation. Well, we've got one turning point, it's -1 and -1. We're going to have to find out what the x coordinate is right here. Well, what do? Well, we know now that a is 1 and b is -1, so that we know that the function is x cubed plus x squared minus x. Well, then all we do is we take the derivative and make it equal 0, and we should get two turning points, two values that make it 0, because we care about where the gradient equals 0 when the derivative, which tells us all about gradients, is equal to 0. So we take the derivative. We know from back here that now this a is 1 and this b is -1. So that's your function. Just take the derivative. It's 3x squared plus 2x minus 1. We want to make it equal 0. Then you factor this. 3x times x is 3x squared. Minus 1 times positive 1 is -1. And if you put the 1 here, you've got plus 3x minus 1x. That gives you the 2x. Well, there's two answers here. Hey, I'm glad it's x equals -1 because that was our original turning point. The other one must be 1 over 3. X equals 1/3 makes this equal 0. So that has to be the x coordinate of r. Now the last question says, write down the coordinates of a turning point of a new function if the new function is defined as twice as big as f of x and then 4 down. Well, all you do is you take the original turning point as x is equal to -1. So you take f of -1, what the actual value was, and f of -1 was -1. And you go 2 times -1, and then you subtract 4. They're telling you to take away 4. Take the value of f of -1, you know, what the y value is, which is -1 right there, multiply it by 2 and subtract 4. And that's what you do. -2 minus 4, that's why you write a -6 here. If you multiply this by 2 and take away 4, what it's going to do, you're not going to change the x coordinate, but you're going to drop way down to -6. And that's why that's your answer. And there you go.